Hello everyone, this is Sanjay from the Australian Institute of Advanced Studies, and today we're going to be learning about radians, degrees. So what is a radian, what is a degree, and how can we convert the two units of measurement? Okay, so radians and degrees, hopefully you may have heard of these before. Radians and degrees come from measuring the angles within a circle, within our triangles, and all of that. So in a circle, we should know that we have 360 degrees in any circle. Okay, so 360 degrees is a full revolution. Starting from here, if I walk around here, I've rotated 360 degrees. The other unit of measurement that we find is called radians, and radians are also a unit of measurement for the angle in a circle, and they come as 2 pi radians is a full revolution around any one circle. So radians are a more pure mathematical way of measuring an angle, whereas degrees are quite arbitrary. They help most common people approximate angles and estimate them in the real life, right? Radians is a more mathematical way of measuring an angle, and it enables us to do more accurate calculations. So what is a radian? Where does a radian actually come from? So the radian comes from if you have a circle with some radius r, okay, so some radius r, if you were to stand on the outside of the circle and walk the equivalent distance r around the edge of this circle, the point you'd land is here, approximately. If we draw a line back to the center, the angle we get here between these two lines is 1 radian. So the radian is a measure of how many times a radius have we walked around the outside of a circle. Okay? So to give another example, if I had a rope that is pinned to the ground and I was standing on the outside I was extending that rope and standing on the outside, and let's say that the rope I'm holding is 10 meters long. If I then, whilst keeping the rope tight, walk in a circle around the point, if I were to walk a distance of 10 meters, the angle I would get here would be 1 radian. If I was to then walk a distance further than 10 meters, in fact, walk a distance of 20 meters, the angle I would get at the final point I started, the final point and the point I started, would be an angle of 2 radians. So radians is a measure of how many times a radius have we walked around the outside of our circle. So we get the formula that the number of radians multiplied by the radius itself, the distance of the radius, is equal to the arc length that you have traveled around the circle. So what that means is the number of radians, in this case 2 radians, multiplied by the distance of the radius, in this case 10 meters, is equal to the length of the arc being this curved line here, the outside of our circle. So 2 radians times 10 meters gives us our result of an arc length of 20 meters. Okay, so radians, being more pure mathematical, actually ties into another very important number within mathematics, and that is the number pi. So where does pi come from? In a circle, if we have any given circle like this, if the circle had a radius r, no matter what that radius was, it could be 1 meter, 2 meters, 3 centimeters, 500 kilometers if we wanted. If we were to start, so the r, remember the radius is from the center to the outside of a circle. If I was to stand on one side of the circle and walk around the circle all the way to the other side, the distance I would travel from here to here is always equal to some number that is close to 3.14 times the radius. So what that means is if my radius here was 10 meters, then if I started at one side of the circle and I walked to the other side of the circle, the distance I would travel would be approximately 3.14 times that radius, so times by 10, which would be 31.4 meters. Okay? Now what you might realize is that pi is actually very close to 3.14. In fact, 3.14 is an approximate value for pi, rounded to 2 decimal places. What they found as they got the distance more and more precise is that 3.14 gets more and more accurate until we get the number pi. So what we found is, in any one circle, if you started at one half of the circle and walk around the outside of the circle to the other half, you would always travel a distance of some number pi, which is approximately 3.14, times the radius of your circle. And that's where the number pi comes from. And what that means is, remember how I said that the number of radians times the radius equals the arc length? That means that in any circle, if you walk halfway around the circle, you will travel around an angle of pi radians. So like I said before, the number of radians times, oh, I should probably expand that. The number of radians times the radius will equal the arc length. The number of radians is pi radians. The radius is 10 meters, and the arc length in this case is a distance from here to here around the circle of 31.4 meters. All right, so we also know, like I've illustrated before, there's 360 degrees in any one circle, and there's 2 pi radians in any one circle. So it's fair enough to say, and it's true to say, that 360 degrees, a full revolution around a circle, is equal to 2 pi radians. So we get this equation here. 360 degrees is equal to 2 pi radians. We can actually now find, now that we know what a radian is, now that we know what a degree is, we can now figure out how can we convert between these two units of measuring an angle. So we have this equation here. 360 degrees is the equivalent of 2 pi radians, and we can start using this equation to develop a way to convert between each unit. So one thing I can do is I can simplify this equation by factoring out 2 from each side. If I divide 360 by 2, I get 180 degrees. If I divide 2 pi radians by 2, the 2's cancel and I get pi radians. And it's exactly like I illustrated before. When we had our half circle, we had pi radians here, and we know that half a circle is the same as 180 degrees. Just like 360 degrees is equal to 2 pi radians, 180 degrees is equal to pi radians. So from this basis, we can now find how do I convert between radians and degrees. The first conversion comes from, if I divide the left side by 180, I must also divide the right side by 180. If I do this to both sides of the equation, what I get is 180 by 180 is 1 degree. And on the right side, I get pi over 180 radians. And that's our first formula. 1 degree is equal to the number pi divided by 180 radians. The second formula we get is if we, starting with our equation here, if instead of dividing by 180, I now divide by pi on each side, on the right-hand side, pi radians over pi is equal to 1, oh, I might actually write that up here. Pi radians over pi is equal to 1 radian. On the left-hand side, 180 degrees over pi, we'll keep it as that, is equal to 180 over pi degrees. So we get the conversions that 1 degree is equal to pi upon 180 radians, and we get 1 radian is equal to 180 over pi degrees. What that means for us is that to convert from radians to degrees, I'm using rad as shorthand for radians. To convert from radians to degrees, we have to multiply by 180 divided by pi. So to go from radians to degrees, we multiply by 180 divided by pi. And to go from degrees to radians back this way, we have to go degrees to radians, we have to multiply by pi upon 180, so we multiply by pi upon 180 degrees. Over 180 degrees. And that'll give us our conversion from degrees to radians. Okay, perfect. So, to erase all this, we now get how do we convert from radians to degrees. So why don't we do some practice with that. In any circle, we know that we have 2 pi radians, 360 degrees. So in any full circle, 2 pi is 360 degrees. We can also draw another circle, halve it, and we get pi radians is equal to 180 degrees. If we had to cut a circle into a quarter, we get a quarter of a circle, and that's actually pi divided by 2, because pi was half a circle, so a quarter of a circle is pi over 2, and that equals 90 degrees. And we can keep going, right? Pi divided by 4 would give us 45 degrees. Pi divided by 6, if we cut this into sixths, would give us pi is 30 degrees, because 180 over 6 is 30 degrees. But to convert it in terms of practicing for any degree or any radian, what we can do is, let's start with something basic. What's 2 degrees into radians? So by just memorizing these 2 numbers here and these 2 conversions, we can do any operation we need to do. So 2 degrees into radians, if you're going from degrees to radians, you multiply by pi over 180. Okay? So how do I do this? 2 degrees, and I'm converting it to radians, so I multiply by degrees to radians, pi divided by 180 degrees. Now, why does this work? On the top, we have pi radians. On the bottom, we have 180 degrees. What will happen is the degrees will cancel as a unit, and we'll be left with radians. And so when we simplify this, we get 2 times pi is 2 pi over 180. And what we're left with, the degrees have cancelled, is radians. We can simplify this if we want, and we can cancel out or factor 2 out from both sides of the equation, both sides of the fraction, and we'll get pi over 90 radians. Okay? So we can double check this. We know that if 2 pi radians is 360 degrees, then 1 pi radian is 180 degrees. So we can replace pi with 180 degrees and divide it by 90, and we get back our original unit, 2 degrees, that we started with. So that's how you convert from degrees to radians. It's as simple as multiplying by pi over 180. The reason we have 180 on the bottom is the degrees will cancel, and the reason we have radians on the top is we'll be left with radians, and that way we can convert from degrees to radians. Now the exact opposite happens when you convert from when you convert from radians back to degrees. So we can do an easy example. If we were to convert pi over 2 radians into degrees, the way we would do that is radians to degrees. You multiply by 180 divided by pi. So pi over 2 radians multiplied by 180 degrees over pi radians, right? 180 degrees over pi radians. Now, like I said, the exact opposite happens where the radians will cancel and we'll be left with degrees, and that's how we're converting from radians to degrees. So to simplify this, the 2 pi's, the pi on the top and the pi on the bottom, will also cancel, and we will get 180 degrees divided by 2, which is 90 degrees. So pi on 2 radians is equal to 90 degrees. Okay? Awesome. So another example, sometimes when you're given radians, you will not be given pi in terms of that, into that number. So an example might be, how do we convert 2 radians to degrees? To convert 2 radians to degrees, we'll do 2 radians multiplied by 180 degrees over pi radians. What will happen is the radians will cancel, and we'll get 2 times 180 is 360 divided by pi. Okay? One thing that I would like to say though is when you're converting from radians to degrees, you don't want to have pi in that number. Okay? Your final answer, you should type into your calculator 360 degrees or 360 divided by pi, and you'll get an answer of approximately 115 degrees. That's approximate because I do not have a calculator on me at the moment. So there we go. 360 degrees divided by pi is equal to 150 degrees. So 2 radians multiplied by 180 degrees over pi radians is equal to 360 over pi, which is equal to 115 degrees. And that's how you convert from radians to degrees. So in final summary, we have to convert from radians to degrees, multiply by 180 over pi. To convert from degrees to radians, multiply by pi over 180. What is a radian? Like I said, a radian is essentially a measurement of the ratio of the arc to the radius. If your arc is some multiple of the radius, then that is your number of radians inside the circle. And the 3 equations we now get is this conversion here, and the final one is the number of radians in a circle multiplied by the radius of that circle is equal to the arc length around that angle. So the radius times the number of radians gives you the distance of that arc there in any one circle. Okay, so that should summarize radians and degrees. I hope you enjoyed the lesson.